and welcome to this video on simultaneous equations. This is a key topic in the algebra part of your syllabus, which itself makes up the largest portion of your course. Before we get started, make sure you check out mathsquared.org to access further resources and become part of the community. Before we jump into the numbers, we need to understand what we're trying to do with simultaneous equations. Imagine we have two lines, L1 and L2. How do we work out where these lines cross without using a graph? Let's have a look at a typical question. Here we have two linear equations, 2x plus 3y equals 13 and 2x plus y equals 7. The best place to start here is labelling up your equations as 1 and 2, as this is going to make it much easier to keep track of your workings later on, so it's a really useful habit to get into. We're then going to need to eliminate one of our variables, x or y. We should consider which of these it will be easier for. In this instance we have 2x in both equations, so we're going to take one equation away from the other. This will then cancel out the x's. The 3y minus the y will leave us with 2y, and the 13 minus 7 will leave us with 6. This will leave us with 2y equal to 6, and therefore y equals 3. So far then we've worked out our y variable, but we still don't know what x is. To work x out, we can pick one of our original equations, whichever is easiest, and substitute our value of y into it. So we can pick equation 2, 2x plus y equals 7, and substitute y equals 3 into it. After a little bit of rearranging, we can see that x equals 2. And there we have our final answer, x equals 2 and y equals 3. To visualise this, we could plot these equations on a graph and see if our solution is right. You may or may not be comfortable plotting these lines, but you should recall that we would need to rewrite these into the form y equals mx plus c, where m is the gradient and c is the y-intercept. Pause the video a moment and try and rewrite these equations yourself. This is also an important skill to have for your GCSE exams, so it's important that you feel comfortable doing this. Now that we've plotted these two lines, we can have a look at what the answer should be. You can see that these lines cross at the point 2, 3, so our solution is correct. Let's do another example. Here we have two equations again, 4x minus y equals 8 and 6x plus y equals 22. Once again we're going to label these equations as 1 and 2. We need to eliminate either the x or the y variable, so we need to consider these separately. Look at the x variables and look at the y variables. Which of these is going to be the easiest to eliminate, do you think? Well, if we add the two equations together, you might notice that the y's are going to cancel out. The 4x plus the 6x is going to give us 10x, and the 8 plus 22 is going to give us 30. So 10x equals 30. So x equals 30 divided by 10, x equals 3. Now we need to go back to our equations and try and work out what y equals. You could work this out from either of these two equations, but I'm going to use equation 1. So we can substitute x equals 3 into this equation and rearrange it and make y the subject. This will give us an answer of y equals 4. Together with our previous answer of x equals 3, we get our final coordinate or solution. Let's plot these on a graph and see if our solution is correct. Once again, to plot these, we're going to need to get them in the form y equals mx plus c. So pause the video here and try and rearrange them yourself. As you can see, the lines cross at the point 3, 4, so our solution is correct. Let's do one final question. Here are two simultaneous equations. Instead of using y and x like we've done previously, we've been given a and b. Now, the maths is going to be exactly the same here. We still need to eliminate one of the variables and consider both. In this question, we can't just add or subtract the two equations to cancel out one of the variables. We're going to need to manipulate one of these equations so we can then cancel out one of the variables. Is there something we can multiply equation 1 by in order to get the a's or the b's to match in both? Now, there is multiple things we could do here. We could times equation 1 by 3 to get the a's to match, or we could times equation 1 by 2 to get the b's to match. In this case, I'm going to multiply equation 1 by 2. In doing so, we're also going to outline the importance of labelling up our equations as 1 and 2, because now we're going to times equation 1 by 2 and rewrite this as equation 3. This will show the examiner exactly what we're doing. We can then take equation 3 away from equation 2 to eliminate the b variable. Then 3a minus 2a will give us just a, and 34 minus 28 will give us 6. So therefore, a equals 6. Now we can go back to our two original equations using this solution of a equals 6 to work out what b is. We can use equation 1 here as it's slightly simpler and straightforward. So taking this equation and substituting a equals 6 into it will give us an answer of b equals 4. This leaves us with our final answer, a equals 6 and b equals 4. So that brings us to the end of this lesson on linear to linear simultaneous equations. If you found any of this challenging, make sure to go to mathsquared.org for further resources and a bit of extra support. Leave a like and subscribe to stay up to date with the most relevant GCSE Maths and A-level content. Thank you, bye bye.